Hi everybody, this is a review of your Unit 5 exam, and this is on the very back page of the Unit 5 exam. So if you want to start by flipping there, that'd be great. If you take a look at this back column, there's two columns, one where I give you the formula and you have to fill in the name, and the other where I give you the name and you have to fill in the formula. So let's start with the top. I gave you the formula. And I'm asking you for the name. So in this formula here, I see 3 capital letters. The key when you see 3 is to go to table E and identify something that's in your compound that's also present here, oops, on table E. And if you look, you probably see this guy right here, phosphate. You never change the name of a polyatomic. You take the name of that right off the table. So what we have in this first compound is something with a polyatomic. And what's with it, if you look at the periodic table, is lithium right here, which is a metal. A metal is with that polyatomic. So this is a metal and a polyatomic. Whenever a metal is first, you always want to look it up and see how many charges there are in the box. If there is only one, then you do not need Roman numerals and parentheses. And so therefore you name your metal lithium and you name your polyatomic. That's it. You don't do anything else with this. Okay? And the next one, there's only 2 capital letters, so we want to identify what those are. So if we look on our periodic table, here is N, here is Cl. They are both nonmetals. So when you have a non-metal to a non-metal, that's when you use prefixes. So this is going to be dinitrogen because if you look at the little subscripts, there's 2 atoms of nitrogen. There's only 1 chlorine. The second nonmetal always gets a prefix. So this is dinitrogen monochlorine. But when it is binary and there are only 2 elements, we go 2 vowels in, drop the I-N-E, and change it to I-D-E, dinitrogen monochloride. And the next one, I see 3 capital letters. So I want to find my polyatomic on table E. And let me look at that one more time. It's ClO4 there. So if we go to table E, you'll see ClO4 is right there. That's perchlorate. So the name, this is a polyatomic. And what's with that polyatomic is chromium, which is a metal. So we name our metal chromium. And then we need to go to the periodic table for chromium to see if we need Roman numerals and parentheses. And if you look right here, there's multiple oxidation states for the metal. So we will need parentheses after its name. I'll fill that in just a minute. We'll go, oh, sorry, that's perchlorate. We'll go back to the polyatomic table and take the name of that right off the table just to review. ClO4 is perchlorate. Okay, now we got to figure out what goes inside those parentheses. So I'm going to do that up here. We have chromium and we don't know its charge. It gets the X. We have perchlorate and we have 3 of those. And according to table E, see that little minus right there? Each of them has a charge of minus, which means -1. And then all compounds are neutral. So bottom times top, X. Use the number outside the parentheses. 3 times -1 minus 3 equals 0. X equals 3. This is chromium Roman numeral 3 perchlorate. The next compound's binary. There's only 2 capital letters. They are 2 nonmetals, so that's when we use our prefixes. This is oxygen. Remember, the first nonmetal only gets a prefix if there's more than 1 of it. Oxygen monofluoride. Second nonmetal always gets a prefix. All right, next one here we have MnCr. I see 3, so we got to find the polyatomic. This guy, Cr2O7. Cr2O7 right here is called dichromate. It has a -2 charge for future reference. So this is a metal. Mn is a metal with a polyatomic. So we'll name our metal manganese. And we'll see if manganese needs Roman numerals. Yep, it sure does. It has lots of charges. So we'll put the Roman numerals in there. Then we'll name the polyatomic off table E, except I can't spell. Oh dear. It did not erase. There we go. All right, and I'll do the math up here. So we have MnCr2O7. Mn gets the X, and remember I said dichromate was -2. Then we do bottom times top X. Now there's no parentheses around our polyatomic here, which means there's only one of it. So X minus 2, you never use the number of the polyatomic. X minus 2 equals 0, so this is manganese Roman numeral 2 dichromate. When you're going the other way, you really care if the name has prefixes or not. If, like magnesium chloride, there are no prefixes, then there are 3 steps. Write down the symbols, look up the charges, crisscross if they don't equal 0. So this guy, magnesium chloride, doesn't have any prefixes, so we look up their charges. Magnesium's +2. Remember the nonmetal, you pick the negative, which is -1. So this guy is +2, that guy is -1. Those don't equal 0. So you crisscross, which means you'll need 1 magnesium and 2 chlorines, MgCl2. The next one does have prefixes, so you don't need to make it equal 0. The prefix becomes the subscript. So diboron means you have 2 atoms of boron. Tetrafluoride means you have 4 atoms of fluorine. Okay? The next one, no prefixes, so symbols, charges, crisscross. This 3 is the charge of nickel. Sulfur is a nonmetal. You have to pick the negative for the nonmetal. So sulfur is negative, that's sulfate. That's a polyatomic. That's here on table E, sulfate. So we have to use SO4 for that, and he's -2. -2 anyway. All right, so he's -2. So nickel, and I remember that sulfate was SO4. We have to use the +3 for nickel and the -2. Those don't equal 0, so crisscross. We're going to need 2 nickels and 3 sulfates. Calcium nitride, no prefixes, so symbols. Look up their charges on the periodic table. Calcium's +2. Nitrogen, pick the first negative. It's the only nonmetal that has more than 1 negative. So calcium's +2, nitrogen's -3. Those don't equal 0, crisscross. Ca3 and 2. And vanadium, this is not a V, it's a Roman numeral 5. So vanadium, they want us to use +5 for that guy. Chlorine's -1. They don't equal 0, crisscross. V1Cl5. So the rest of your test looks like this. This is the front. Number 1, an example of a binary compound, but that means only 2 elements. And the one thing you have to know about binary compounds is they must end in IDE. So if it doesn't end in IDE, like this guy and this guy, it can't be a binary compound. Okay? Now, the other thing that we need to know is that potassium here is an element. It's just K, whereas ammonium is polyatomic right here on table E. Okay? So this guy, ammonium, is a whole polyatomic, which gives us 3 capital letters there. So the right answer has to be A, potassium chloride. It has only 2 capital letters. Which formula represents copper 1 oxide? Again, this name does not have prefixes, so there are 3 steps. Symbols, charges, crisscross. So copper, oxide. Remember, this is the charge we have to use on copper. We go and look up oxygen's charge. Those don't equal 0, so we crisscross. So we need 2 coppers and 1 oxygen. Okay? What is the correct formula for sodium oxide? Again, there are no prefixes, so symbols, charges, crisscross if they don't equal 0. So we need 2 of those and 1 of those. Which formula is correctly paired with its name? Well, this one jumped out at me right away because there's only 2 capital letters and they forgot to change the ending to I. So that is not right. It can't be that one. This one also jumped out on me. This is a metal to a non-metal, and they use prefixes. No, no, no. Prefixes are only used when it's non-metal to non-metal. So get rid of that one as well. So then we're looking at these 2, okay? And both of these are right. What we really just have to check here is our Roman numerals correct? So if we have CuCl2, what should that be called? And if we have FeO, what should that be called? All right, so we know it's copper chloride. The question is, what should the Roman numeral be? So remember, copper gets the X, chlorine gets the -1, bottom times top X, bottom times top -2 has to equal 0, X equals 2. So this should be copper to chloride. Whereas if we do the same thing for the FeO1, iron's X, oxygen's -2, bottom times top has to equal 0. This should be iron 2 oxide. Oops, 2, not 3. So going back to our test, this Roman numeral is not correct. It's not iron 3 oxide. It should be iron 2. Okay? Oh. An atom represented by X forms a compound with the formula X3N2. And they want to know, who could it be? Well, let's figure out what X's charge is. Because if we know the charge, we can figure out which one of these 4 choices has that charge. Remember, the non-metal has to be negative. So this gets a -3 from its box. Bottom times top, 3x. Bottom times top, -6 equals 0. 3x equals 6, x equals 2. So now we have to figure out which of these 4 choices can have a charge of 2. So if we look at CS, right here on the periodic table, it can only be +1. And if you look at aluminum, it can only be +3. And if you look at, I don't know who the other choice was, sodium can only be +1, right? So the right answer is this guy right here because he can be +2. Looks like my choices are in a little different order than yours, so I hope that you're paying attention. Okay? The correct name of the compound with the formula PbO2 is, this is a metal and this is a non-metal. So we do not use prefixes and we may need Roman numerals. So let's check. It's going to be lead oxide. And then if you go to the box for lead, yep, we need those Roman numerals. So we have to figure out what Roman numeral we need. Okay, so we have PbO2. So lead gets the X, oxygen's -2. Bottom times top X, bottom times top -4 equals 0, X equals 4. So we need Roman numeral 4. Which formula correctly represents the compound calcium hydroxide? So there's no prefixes, so we do symbols. Hydroxide's a polyatomic on table E. Charges. This whole thing has a charge of oh dear, I lost it, -1. Okay, I ran out of space. Let me do it down here. Calcium +2, hydroxide -1. Those don't equal 0, so we crisscross. We need 1 of those and 2 hydroxides. And the polyatomic has to be in parentheses. All right, number 8. The molecular formula of a compound is represented by X3Y6. What is the empirical formula? Remember, the empirical formula is always when the subscripts are in lowest possible terms. So 3 and 6 are both divisible by 3. So that's going to give us X1, right? Y2. Yep. Which molecular formula is correctly paired with its corresponding empirical? So we have to be able to reduce the first formula to give us the second one. So if we divide both of these by 2, we would get CH. So that doesn't work. It's not that one. If we divide, and we have to divide them by the biggest number. So the biggest number, these are both divisible by is 6. So that would give us CH for that one as the empirical formula. 4 and 10 are both divisible by 2. So P2, O5. We have a winner. And these are already both empirical. Right? And they don't match. So neither one of these can be reduced any further. All right, number 10. Which represents both an empirical and molecular formula? If it's an empirical formula, the subscripts have to be in lowest terms. There's only one choice where the subscripts are in lowest terms. It's this guy. Number 11, you're counting how many oxygen atoms are there. Remember, when there's a number outside parentheses, you distribute it. And distribution means multiply. So 3 times 3 gives us 9. Number 12, what type of reaction is this chemical equation? I see all compounds, and it looks to me like the Al and the Na swap partners, right? Because originally Al's with Cl, now Na's with Cl. So we call that wife swap or double replacement. Number 13, what type of reaction best describes the equation below? If you look at this, we have oxygen as an ingredient, and we're producing carbon dioxide and water. That is combustion. Anytime you have oxygen to the left and CO2 and H2O to the right, it is combustion. Number 14, when the equation is balanced using smallest whole numbers, what is the sum of the coefficients? So I'm just going to rewrite this equation on the next page here and balance it for you. So H2S plus O2 goes to make H2O plus SO2. We draw a wall and we list and count. O's are what I call funky because there's 1 in this compound and 2 in that compound there. Okay, so this is a tough one because there's no evident easy starting place. My hydrogens are already balanced, my sulfur's already balanced. So, and I don't know really, I guess we could turn 2 into 3, but not easily. So, my little hint or trick when there's no obvious starting place, and it doesn't make sense, but it always works, only when there's no obvious starting place, is to start with the 2 there. Now, I know I just unbalanced some things, but I can go back and fix them. If I made 4 hydrogens, let me change that to a 2. 2 times 2 gives me 4, and it changes my first oxygens to 2. So now I have 4 right now in this. Then I'll fix my sulfurs by putting a 2 here. 2 times 1 sulfur gives me 2. I used to have 2 oxygens there. 2 times 2 gives me 4, plus the 2 in the first compound for a total of 6. Now it's very easy for me to turn 2 oxygens into 6 by putting a 3 there. 3 times 2 gives me 6. So what is the sum of the coefficients? 2 plus 3 plus 2 plus 2, that's going to equal 9. Okay. It's called the 2 trick when there's no obvious starting place. All right, we're balancing this guy. I would not use this trick here because there is an obvious starting place, I think. And I think it's not lithium. It's nitrogen. Because there's only 1 nitrogen on the right. So I'm going to put a 2 here to fix my nitrogens, which is going to give me 6 lithiums and 2 nitrogens. And then I will fix my lithiums by putting a 6 there. And the coefficient of lithium when I'm balanced is 6. Okay. Next, balancing. Some of the coefficients when we're balanced. So let me do my counts. I'll do them up here. ALs I have one of, O's I have two of. ALs I have two of, O's I have three of. So this is a good one for the two trick. No, not really. Maybe least common multiple. I can't turn 2 into 3 unless you use a half. You could. So let's make them both 6. So let's make 6 oxygens there. And let's put a 2 here to make 4 aluminums and 6 oxygens. And then my aluminums, I would need a 4 there. So the sum of the coefficients is going to be 9 again. It's not always 9, I promise you. Number 17, what's the sum of the coefficients? Okay, so we got a balance. So ALs, we have 2. My polyatomic sulfate is together on the left and together on the right, so I'm going to keep it together and just say there's 3 of those. Zincs, there's 1 of. Chlorines, there's 2 of. Aluminums over here, there's 1 of. Sulfates, there's 1 of. Zincs, there's 1 of. And chlorines, there's 3 of. So I'm going to pick somebody that's not balanced, and that's going to be easy to fix, which looks like aluminum. I just have to put a 2 there, and that changes my chlorines to 6. And then my sulfates seem pretty easy to fix. I'll put a 3 there. It's going to change my zincs and my sulfates to 3. So then I just have to fix my zincs, and in the process of fixing my zincs, I also fixed my chlorides. And what do we got for, oh, look at that. The sum of the coefficients again is 9. 5 and 3 is 8. 8, don't forget there's a 1 here, right? So that's 9. Not always 9. Don't always pick 9. All right. See, look at this one's not 9. Another balancing. I'll do my counts over here. AG, there's 1. H's, there's 2. S's, there's 1. And over here, AG's, there's 2. H's, there's 2. And S's, there's 1. Okay. So it looks like everybody's balanced except AG, which is a pretty easy fix just by putting a 2 there. And so what's the sum of the coefficients? 2, 3, 4, 5. Remember, these are 1s. That was an easy one. All right. A compound is made up of iron and oxygen only. The ratio of iron to oxygen ions is 2 to 3. What is the name of this compound? So if the ratio of iron to oxygen is 2 to 3, that means the subscript is 2 and 3. So we don't use prefixes, so we can get rid of that. We don't use prefixes because this is a metal and it's a nonmetal. We only use the prefixes when it's nonmetal to nonmetal. And we know it needs Roman numerals because the only choices that are left have Roman numerals. But again, the reason it needs Roman numerals is because iron has more than one charge in its box. Whoops. I forgot where I am here. So what is the charge going to be here? So we have Fe2O3. This is the X, that's -2. I got that from its box. So bottom times top, 2x, bottom times top minus 6 equals 0. 2x equals 6, x equals 3. Iron 3 oxide. Oh boy, this is a lot of reading. Write the formula for the primary metal hydroxide used in the lantern. The primary metal hydroxide is yttrium hydroxide. So no prefixes, so symbols. Charges, if you've never heard of yttrium, it is right here. It's +3. This is +3. Hydroxide's at polyatomic. This whole thing is -1. That doesn't equal 0, so you crisscross. 1 yttrium, 3 hydroxide. All right, that's it, everybody. I hope you found this helpful. Good luck on your test. Bye-bye. So they get smaller because the electrons get more attracted to the nucleus, which shrinks the atom. more energy.